Good evening, everyone. On the behalf of Department of Mathematics, Wilson College Autonomous Mumbai, I welcome you all in the today's session. Our today's guest is Mandar Khasnis, sir. He is an associate professor at Department of Mathematics, Srimati CHM College, Ulhasnagar. He will deal with the topic of functions of one variable today. Over to you, sir.
Yeah. Thanks a lot. I once again thanks Wilson College, for giving me the opportunity to interact with the students other than our college students. So hello students. I think in the last session, if you remember, we started with the continuity, limits continuity discussion we had. So let me present my screen. My laptop suddenly started behaving little slow. But meanwhile, I have posted one link uh, in chat box. Could you see the link?
Yes, sir.
Yeah. So I think, as I announced in the last lecture, today it is just problem solving day. So we are just going to, try working with different problems and then discuss any specific topic, as and when required. So let's go ahead. I'm trying to share, but I have issue with my laptop. Let's see. It's taking little time, but you can go ahead. So that's why I just shared the link. I hope you could access the file problem sheet.
Yes, sir.
Right, great. So yeah, I think now my screen is visible. Is it?
Yes, sir.
Great. Chalo. So let's begin with today's work. Mm, okay. So let me go to the directly to the next page. I think I have to turn off my video so that my laptop will. So please excuse me for this. I have to. It's taking energy. Yeah. We can start with the first question first and move on quickly to the further
Hello. Hello,
questions.
sir.
Yeah. Yes.
Sir, it's a request. Sir, in
Huh.
the previous class, you have given total 15 questions to solve.
Huh. Right.
Sir, actually, I have solved actually all of the questions. So, sir, can
Huh.
you
Huh.
confirm what are the answers of those questions?
Oh, I think I have not noted down the answers. So even I have to work it out again to check the answers. But what I request is you can discuss with your peers, and if there is a doubt, of course, I am there to help you out. Is that fine? You want me to declare the answers to you? Then I can share the answer sheet. But I usually we avoid doing that um,
Sir,
because
actually,
then people stop thinking. Huh.
solve the question, but we need to
You are not sure about the
verify.
answer, you mean?
Sir, actually, sure about, but some of the questions actually I need to see
Uh,
whether it is.
Fine. See, what I suggest is first discuss amongst your peers. That is important discussions. And if still there is a doubt, then I am there. So you can. I think my number can be shared with these students, and then you can directly contact. Or if you ask your means there is some teacher right in the group, Wilson College teacher. You can ask them, and I will post the answers if you wish to. Okay, so I think that is okay, Sunil.
Yes, sir. Okay.
Yeah, I'll be posting the answers if you ask for it. Fine. So don't worry. Right now
Thank you.
we'll move. Yeah. Right now, what we'll do is, because there are more problems waiting for us to get discussed. No, so we'll enter into that, and yes, we can revisit the sheets again later on. Fine. So let me move into. So I'm glad that people have tried working with the problems, and yes, that is what we expect and we are happy with. So shall we begin with today's work? Some few questions. Again, we can't solve all the questions in 1 hour, but few at least we will touch upon. So first one, let's begin with the first question itself. Don't disclose the answer. You try it out. I'll wait for 2 minutes, and then we will discuss the solution. So I have trouble. Okay. So has anyone got the answer?
So is it infinite?
Okay, one answer is infinite. Um, let's see. No, it's not the correct answer, but fine. Uh, any other answer? Now, as I disclose, it's not the correct one. So, there are three more choices now. It could have been correct if uh, the word continuous is not there. That's a hint. Continuity forces, I mean, reduces the options. So, what shall we do? My laptop is hanging. Let's see. So, what do we do? What we have is, I don't know what is happening. Okay, fine. I'm writing, but it is not. I'm sorry for this. I have no control. So, can I write like f of x square? In fact, f of x is equal to plus or minus x, kind of. right? Can we write something like this? The options
Yes.
for fx is either plus x or minus x. That's what we can have. So now we have to adjust this throughout the interval. So what I can do, I could have taken fx equal to x. In fact, for all x over minus 1 1, right? Or what I can do is fx equal to minus x for all x over minus 1 1. Both these functions satisfy this equation. So definitely two are surely there. Anything more और कोई हो सकते हैं क्या?
Some modulus function.
What what we are trying to say is any combination of these also can be tried out. So sometimes it is like x, sometimes it is minus x, but we now want to maintain continuity. So if you want to maintain continuity, what you can do is, in fact, it's like 0 less or equal to x less or equal to 1, and minus 1 less or equal to x less or equal to 0. Continuity is maintained, and this is basically mod x. So this is definitely the similar, I mean, it is going to possess this property. And now you can guess the one more, I mean, another one as well. What is it? रोल चेंज करो, यहाँ पर माइनस एक्स लेंगे, 0 लेस और इक्वल टू एक्स लेस और इक्वल टू 1, एंड एक्स minus 1 less or equal to x less or equal to 0. You get me? So it's something like you have actually two lines. One line is this, ये this is what I'm plotting, and the other line is this. So possible graph should be coming up from these lines only. So either I will take this or I will take this down part I mean part, or it is whole line this or whole line this. I cannot take this part because obviously it's not a graph. I cannot take this part. So at the most we can take 4. This is happening. Please understand that we are using continuity because function is not required to be continuous. If I remove this, if I ask the number of functions f from this to this satisfying this equation, then what would be the answer? Then the answer is going to be infinite because you have choices ना. कभी कभी x दो, कभी कभी minus x दो, कुछ फर्क नहीं पड़ेगा. Function will be discontinuous, and so you, how many choices do you have when to give x and when to give minus x? Infinite, uncountably many choices. You understand this point what I'm saying? So continuity is something which reduces the options to 4, and so answer is 4 if I am looking at continuous functions. I hope the argument is clear to everybody. Shall we make a move to the next question quickly?
Yes, sir.
Yes. You can stop me if you have any doubt. Don't keep it with you. You can share your doubt so that बाकी भी किसी का डाउट होता है वो क्लियर हो
Hello,
जाएगा.
sir.
Let's. Yes.
Sir, can you show the previous slide?
Yeah, just a moment. I'll paste this somewhere and then I'll show you. Sorry. Yeah, I'm going back. Yeah, here it is.
Sir, here we can clearly see that the linear
Hmm.
function f of x is equal to x is a continuous
Hmm.
function in the domain
Correct.
minus 1 to 1 to r.
Correct.
It is a fact that if a function is continuous, then
Hmm.
any linear multiple, any constant multiple of that function is again a continuous function.
Correct. Correct.
So, sir, between minus 1 to 1, there are
Hmm.
uncountable number of constant function. So that is
Yes.
So can we multiply that number with x? So we will have
Uh,
uncountable number of function.
yeah, yeah. We can try 2x for that matter.
So
You mean
like
like this, na?
half of x, 0.3 of x, something like.
Okay, okay, okay. So less than 1 you want to take. Say x by 2, for example.
Because our domain is -1 to 1, na? That's why.
But doesn't matter. Codomain is R. So whether you take 2x also, x is coming from -1, 1.
Okay, sir.
Images need not be in -1, 1. Right? Codomain is given to be R. But anyway, you can look at x by 2 for that matter. It's okay. But then what will happen to fx square? It is x square by 4 and it's not equal to x square. Whereas our condition is this.
Okay, got it, sir.
Yeah, yeah. So this condition satisfying this condition, there are only, I mean, you can't have the multiplier other than 1. That is the problem. 1 or -1. That's it. Yeah,
Okay, sir.
good. Fine, fine. Nice. Okay. I am going just back to the second question. Yeah, this is, I think, a famous one. I hope people know behavior of such a function, but still, if you want, I can quickly brush up because this is typical one, jam, typically jam question. Sine 1 by x is a famous fellow, is it?
So it is a continuous function.
Yeah, correct. You are correct. It is a continuous function, x square sine 1 by x. Can you throw some light on this? Gx equal to sine x for x non-zero, and I can take 0 for x equal to 0, suppose. So this is a function from R to R defined like this. What do you know about it? I mean, anyone can answer first. Is this continuous at 0?
Yes, sir.
Okay, just sine x, huh?
Or no, sir. It will not.
So I'm asking what is limit x goes to 0 of gx?
So it will fluctuate between -1 to 1.
So quick observation. See, others also can, I mean, can say, you can even say you don't know, sir, tell me ye kya hai. You can say that, it's fine. And if you also know, then I will not take my time in explaining this. So अगर बहुत लोगों को पता है तो फिर हम आगे जाएंगे. हाँ, तो मुझे बिंदास बोलो कि सर ये पता है, आगे जाते हैं. Because I think Sunil knows it. Sunil, na?
Yes,
Fine,
sir.
fine. Yeah. Let's quickly brush up because I think there are others are not that comfortable. See, easy thing. If you look at sine, uh, I know we already know that sine n pi is 0 for all n. Let's stick to naturals for time being. It's true for integers as well, but right now naturals. So that means I want 1 by x to be n pi. That means if I take xn as 1 by n pi, then what we know is g of xn is 0 for all n. Okay. So if I try to draw the graph, what is going to happen to the graph is, okay, and let me have this as -1 and this, sorry, +1 and -1. Okay. And now if you see n equal to 1, then somewhere here I do have 1 by, sorry, 1 by pi somewhere. I do have 1 by 2 pi. We do have 1 by 3 pi and so on. And at all these points, the function is 0. But on the other side, if I look at yn is equal to, अभी sin 1 कब होता है? We can adjust that. Say sine of what we know is, I'm writing directly 4n plus 1 pi by 2 is 1 for all n 0, 1, 2, and so on. Okay, sine pi by 2 is 1, sine 5 pi by 2 is 1, sine 9 pi by 2 is 1, and so on. Sine 3 pi by 2 is minus 1. So 4n plus 1 times pi by 2 is 1. So if I take yn as 2 upon 4n plus 1 pi, मतलब इसका reciprocal, then what we know, g of yn is 0. Sorry, g of yn is 1 for all n. Is it fine? That means ये अभी 2 upon n equal to 1 means it is 2 by pi. So 2 by pi is somewhere here, and so this is supposed 2 by pi, and the corresponding sine value is 1. Then you can see that it will come down to 0 at 1 by pi, it is 0. It will come further down somewhere between these two, it will be minus 1. Then it will be 1 in between. ये से 1 होगा, फिर वापस वो नीचे आएगा, इधर 0 बनेगा, वापस डाउन -1, देन अगेन 1 एंड सो ऑन. अब ये कितनी बार ऑसिलेट होता रहेगा? It will keep oscillating because this sequence is converging to 0. So at every 1 by n pi, it's going to be 0. At the same time, at every 2 by 4n plus 1 pi. Now, this is also a sequence which is converging to 0. So as you approach near to 0, it will have infinite oscillations. And similarly, on the left side also, it's a odd function. So similar behavior. यहाँ पर समवेयर यहाँ इधर कहीं तो 2 by pi होगा, -2 by pi. तो जिधर वो -1 होगा, and then it will come up like this, and then it will keep oscillating. -1 1 -1 1. Okay, this is a rough sketch of the graph that we have. So I mean, if I'm asking what is this limit, then this limit does not exist. Why? Because via one sequence, if I approach to 0, then the corresponding gxn is going to 0. Whereas if I approach to 0 via this sequence, corresponding g approaches to 1, converges to 1. That cannot happen. You remember the limit sequential criteria for limit? So whenever limit x goes to p of g of x, if I want to say it is L, then this is if and only if for every sequence xn converging to p, g of xn must converge to same L. But here g of xn is converging to 0 and g of yn is converging to 1. That cannot happen. If that is happening, that means the limit doesn't exist. Okay, so this limit is not existing if I am having only sin x. But something useful happens when we multiply by x or x square. And I'm not going to, because the whole lecture will go just in this discussion. So I'll just disclose, you try to see why it is true. So point is, I'll quickly mention these facts, that limit x goes to 0 of x sine 1 by x not only exists, but it is 0. And that's easy to observe because this is a bounded function and limit x goes to 0 of x is 0. So f into g, where g is bounded and limit f is 0, f into g का limit भी 0 होता है. ऐसा एक अलग अलग result है जो use हो सकता है. Then I mean, another observation is limit x goes to 0, x square sine 1 by x. This also is going to be 0 in that sense, because x square is also going to 0 as x goes to 0. But so this is okay. This is same thing as f of 0 in our case, f of 0. So continuity is definitely there. It is continuous. Continuous तो है ही वो at 0. लेकिन इसका डिफरेंशिएबिलिटी भी चेक करना है. सपोज डिफरेंशिएबिलिटी तो क्या करना
Sir,
पड़ेगा? हाँ,
sir, it is differentiable.
very good. Because you just look at fx minus f0 upon x minus 0. but that is x square sine 1 by x minus 0 upon x. That is x sine 1 by x. But x sine 1 by x का अभी अभी हमने बोला कि limit is 0. So this limit will exist. Limit x goes to 0 of this is going to exist. That means function is differentiable as well. लेकिन फिर भी हमारा करेक्ट ऑप्शन दिखाई नहीं दे रहा, क्योंकि ये तो रूल आउट हो गया, ये भी रूल आउट हो गया, नॉट डिफरेंशिएबल नहीं है। लेकिन डिफरेंशिएबल ओनली वंस है के नन ऑफ एबीसी है, ये देखना पड़ेगा। तो कैसे इसका अभी कैसे डिसाइड करेंगे सी ट्रू है कि नहीं?
Sir, we can find the second
हम्म,
derivative and then apply.
करेक्ट। सिंपली अप्लाई u into v to get the
Yes, sir.
second derivative, and you will realize that cos 1 by x will be one term, okay, somewhere. So try it out, work it out, and see whether it is differentiable only once, or I mean it is differentiable there. What will happen is, so when I apply u into v, there will be a term x 2x cos 1 by x. Sorry, not 2x, 2x sin 1 by x. This will be one term, isn't it? u into v जब लगाएंगे तो प्लस समथिंग भी होगा, बट इसमें से 2x sin 1 by x is not going to be differentiable. So it is differentiable only once at 0, not twice. Second derivative नहीं exist होगा इसका. So I'm just declaring the answer, but I want you to work it out. You know what is to be worked out?
Yes, sir.
Good, fine. So I will make a move because we have more things to do. If you're not clear, please ask. I'm going back to fine third. You can think about f of x plus y is fx plus fy for all x and y
Hello,
in R. Yeah,
hello.
yes. Tell me.
Yes, sir. Am I audible?
Yeah, Supratim, tell me.
Okay. I'm checking, sir, whether is my microphone is working or not. Sometime it
हाँ
will not
तो
work.
yeah,
That is
no
why.
problem. Yeah,
You can proceed, and whatever problem arise, we can tell you.
no problem. Yes, okay. Thank you. So, third one, any answer? This is again a typical one, function equation. F of x plus y is fx plus fy. Will
Sir,
force the
this
function.
this
Huh.
one name is Cauchy function. Sorry.
Ah,
Yes, and
some
it will satisfy some linear equation, some x plus b or
uh,
a
so what kind of function f of x plus y, I mean f of x will be?
f of ax plus b, something like that.
So it will be
Mhm.
k of x, where k will be an integer.
K into x, you mean?
Yes, sir. Yes, sir.
Ah, okay. Where k is integer, you want to say? Mm-hmm. Mm,
It
I
may
doubt
be
because huh,
real number, actually.
means if I take fx equal to some any kx for k belongs to R. Okay. For example, if I am taking say any k, so k positive लेता हूँ मैं फिलहाल. Now, does this satisfy the? So if I look at f of x plus y, it is k times x plus y, which is kx plus ky. So it is fx plus fy. Okay, but yeah, that's a good observation, and one can actually prove it. Okay, if somebody wants to prove that fx is of this form, then that can be done. All right, how to prove? You have to prove for means
For
naturals.
proof, it is
Uh,
first we try for natural number, then integer, and after
very
that,
good. Correct. So you can go up to rationals, like you can
yeah,
prove that f of a by b or m by n, I'll write if you are comfortable with m by
yeah.
n, is some constant times m upon n. That you can write. I mean, you can prove.
Yeah.
by actually using this. Now, from rationals to reals, if I want to shift, ultimately I want to show fx is k times x for all x in R.
Yes.
So यहां तक का काम जो है ना, यहां तक का, this is algebraic work, because you just have to use this.
Yes.
Understand? So if I want to write f of 3, then I can write it as f of 2 plus f of 1. But that is f of 1 plus f of 1 plus f of 1. So that is f of 1 times 3. So this is what your k का रोल कौन प्ले करने वाला है, f of 1 actually. So f of 3 is k times 3, where k is f of 1. So fine, this you can do. This is all algebraic steps. But from here, that is when you get it for rationals, and you want to now get it for irrationals as well, the same property, then you require continuity. Okay, from here to here, the travel is via continuity. If continuity is not there, यहाँ तक आपको आने वाला है, without continuity you will get this. It is algebraic argument. But from here to here, if you want to say it for every real number, you will require continuity, will force you to get this equality. Understood?
Yes, sir.
Why is it so? So I'll just state a result if you are not knowing. So if I have a function, two functions, say f and g, from R to R, okay, continuous, such that fx is equal to gx
For all rational.
in Q, then
Re-
fx is equal to gx
Yeah.
for all x in R. That's
Because, sir,
uh,
it is hold for this Q is dense in R.
very
Whatever.
good. Correct. Q is dense, and hence it happens. It is true in general for any dense subset.
Yeah.
Good, good, good. Correct. So now it is obvious. Means once you have f of x is equal to kx, you once you got the form, now use this and decide f of pi. So this will tell you what is your constant. So f of e is k times e, which is given to be pi. So that tells you what k is, pi by e. So if somebody asks me what is f of pi, what I will simply write is it is pi by e times pi. So that is pi square by e. That's what your f of pi is going to be. Okay.
Yes, sir.
Yeah, yeah, good. Um, I think we'll make a move to, sorry. So 4, I am dumping on you. Try at home. 5, we'll not discuss much, but at least look at it, and in a
Yes,
minute
sir.
will go ahead. So just look at it. Don't disclose the answer.
Five.
Fifth one.
Okay.
Yeah, yeah.
Sir, excuse me.
Yeah.
Sir, entire discussion should, I think, in English, because here are some student, they are not
Yeah, yeah.
understanding. They are not
Okay, okay. Yeah,
understanding
yeah.
the Hindi.
Okay, okay. Great, great. No problem. Thanks for this
Yes, yes.
information. I'll do that.
Sir, f of x is not continuous and g of x will be continuous.
At 2.
Yes, sir. Sir,
Fine.
because it is
Hmm,
the greatest integer function, so when we
hmm,
find the left hand limit, so it
hmm,
will be having different limits on the left side and from the right side for f of x.
hmm, hmm, hmm.
So
But
limit,
for Gx, there is anyway, Gx is totally a continuous function, so there is no issue.
Yes, sir.
And what about fx plus gx?
So 1 minute.
Sir, f of plus gx, it will be not continuous at 2. Only if we multiply, then it marks the effect of the more greatest integer function. I think f of x gx is continuous at 2. I'm just
Okay.
just seeing without any
Hmm.
calculation.
Hmm. But I'm curious to understand. It is
X
not greatest
square.
integer of x. It is
Oh,
of x square. So is it behaving similarly like x, or it has some difference?
it is only x square, third bracket x, or greatest integer of x square. Okay.
Greatest integer of x square. Correct.
Then I think it will not affect. It will affect at root 2. I think not in 2.
Uh, uh, where will it change its behavior? That is interesting.
Yeah.
So if I'm looking at floor of x square, or I mean greatest integer of x square, exactly. So if I'm between 0 and 1, 0 less or equal to x less than 1, then even the square will be less than between.
Yes. Yes.
I mean, so floor will be 0.
Yes.
But now 1 less or equal to x less than root 2,
This will 1.
this will be 1. Then root
Root
2
2
less
to
or equal
root
to
3.
x.
Root 3.
Less than root 3. It is
It will
going to
be
be
2.
2. Then root 3 less or equal to x less than 2. It is 3. And 2 less or equal to x less than root 5. So again, it's not a big deal. It's 4, right?
Yes, sir.
So anyway, at 2 it is changing its behavior. Hmm. Am I correct? Let me check once. Hmm. Yeah, yeah. So not making any difference in the answer. It's still. Hmm. So gx is continuous is fine. This is unfortunately not becoming continuous, right? Because at 2 it the behavior is different. Left side and right side for floor x square.
So product will be
Huh?
continuous because product will be continuous.
Because
As
Okay.
part
sine pi,
of sine pi
as
x.
sine, as sine pi x tends to 0 and it
Yeah.
overall will tends to 0 and
Yeah.
we
Yeah.
will let sine pi x and cos pi x.
As x tends to 2. Right,
Yes.
right,
Yeah. Yes, sir.
right. Correct. That's a good observation. So this continuity, you mean you are going to get.
Yes, sir.
Yes, sir.
Right. Okay. At 2. So yes, correct. You are going to get this. And this cannot happen because gx is
Surviving this term.
continuous. Gx is continuous and fx is not. So the addition can't be continuous. Because if addition is continuous, then addition minus gx becomes continuous, but that means fx is continuous, but that's not
That is not possible.
right. Okay. Yeah.
Sir,
Good. Huh?
it can be rethink as
Hmm.
one of the if one of the function is discontinuous and other function is everywhere continuous, then their product may also continuous, but individually
Yes.
need not this
Correct.
continuous.
So as an example, you can look at it. Correct. Good. Yes. Fine. Okay, I'll make a move to something else. Uh, it's okay. In fact, even seventh can be discussed on similar lines. Sixth, seventh, I'm skipping.
Yes, sir. We will
Simple
trying.
ones. Look at eighth for that matter. Let's quickly rush through. Yeah, this you can guess it is based on what? Yeah, can somebody comment on like it is based on what? Any comment?
I think, sir, it is I think AMGM inequality something or properties of definite
Uh,
integral.
no, no. I mean, it's fine. MGM is it is not required. MGM is not required.
Yes, sir.
Uh, See, you are trying to say something about there exists such that fx equal to something. See, so when in which result you conclude that there exists some point such that f of x is equal
Intermediate
to
value property.
exactly. That's the point. Okay.
Yeah,
Intermediate value property is
yeah,
what
yeah.
I oh sorry. Undo. That's what I want to use. So how do we does everyone knows IV intermediate value property or intermediate value theorem? I'll quickly brush up. So if you have 2 points A and B and FA is somewhere, f of B is somewhere else, and you have some function. Now pick up, so this is your f of A, suppose, and this is your f of B. Then take any k between FA and FB. For this k, there will always exist at least one C such that f of C is k. There can be many more than one also, but ek to definitely there is always one, at least one C. So there exists C between A and B such that f of C is k. This is always true for any k between f and fb. This is what intermediate value theorem for continuous function is. So if I look at A, what is this object? F0 plus f1 by 2. Now you can tell me AM or GM, whatever. So this is
AM of two value.
AM, correct, of two values, that is F0 and F1. And we all know that arithmetic mean always lie between
This value, between this value.
these two values. So can I apply? Am I having such a situation? FA and FB, there is somebody. So this is behaving like our K, and this is like FA and FB. So if K is between FA and FB, then this must be a pre-image. I mean, this must be a image of somebody, that is there exists some X such that f of X is K. This is what we are saying. So A must be true. I mean, so I cannot tick it because what is asked is something not true. So this is true. But then B also you can tell me quickly.
That is the geometric mean.
Correct. Geometric mean of f of minus 1 and f of 1. And it also lies between f of minus 1 and f of 1.
Yes,
Geometric
sir.
mean of two numbers also is going to lie. It always lie between those two numbers. So this is also going to be true by intermediate value theorem. Now, how about C? For integration, now what one has to think.
Sir, it
Ah,
will be constant.
okay. Integral.
Yes, yes, okay, okay. For such
Um,
value, existence of such value x such that.
okay. See, my point is, I mean, if I am concentrating on this function, means let us restrict the function on minus 1, 1. Okay.
Yes,
Now, same function. So, it's going to be continuous anyways, because it is restriction of the original continuous function. And now, because I am talking about closed and bounded interval, f is bounded. In fact, it attains its supremum and infimum. I don't care if I am writing, can I write something like this? For all x in the interval minus 1, 1.
Yes, sir.
Now, what you do, in fact, I will require the information that it attains its bounds. You remember this result? If function is continuous on closed and bounded interval, we recollected that there exists p and
yes,
q
yes.
such that f of p is infimum and f of q is supremum. So, suppose this is what I have. Now, what you do is you integrate over minus 1, 1. So, what you get is f of p minus 1, 1 dx less or equal to minus 1, 1 fx less or equal to f of q into minus 1, 1 dx. So, this is 2, by the way. So, what I get is fp less or equal to minus 1, 1 fx upon 2 less or equal to fq. Isn't it?
Yes.
But this doesn't solve our, I mean, our problem, because what I'm trying, is I'm trying to see whether this can be made sitting between two images like this.
Yeah.
But in the process, something, I mean, this is of no use for us, because for this there
Sir,
is definitely, yeah.
you can use 2a as a function 2x. That is, then it will cancel by
But
2.
that we have, means we can't do that, no, because
Yes.
this is
Mm.
so this is of no use, unfortunately. But this may give us a hint that then this might not be true. So you can try D first. Can I try D? So if I would have same lines, so I would have had 0 to 1. So then 0 to 1, the integral is 1. Understood. So this 2 will not be there. It will be just 1.
And it
0 to
will
1
hold true.
fx. Yeah, and it will hold true. So this will be true.
And then C for
Then C is,
MCQ,
I
Must
only
be
on
true.
mean,
F.
if you believe on the paper setters, this is the one which is false. But yeah, I now what I would request is, then I have to prove it, that
Yes, sir.
this won't happen. So that I
For
uh,
proving this, only one example is sufficient.
yes, correct. You can produce a function continuous such that this won't happen. So this is I'm putting on you. You can try it out, right? To actually prove it. But as far as exam is concerned, you can rule out quickly the other three options. because there it is just MCQs, so you have to manage it quickly. Okay, but yes, I mean it's easy to construct an example, not a big deal. It can be done. Right now, I'm not doing it. I'm moving to another question. We are short of time. Is it fine? May I go ahead?
Yeah, yeah.
Yeah, yeah.
Yes,
Now
sir.
the yeah, thanks. So ninth one is actually Lopitol. So I'm just declaring it. You just apply Lopitol, and you will be, because it exists, is the information given,
So it can
and it
be.
is.
So
Yep.
we can do this.
Hmm. Yeah, you can do. Thanks. That's good. So you can
You can
handle this.
skip it.
Yes, yes.
Yeah, I'm making a move to the next sheet. Yeah, this is. Can we try 10th? So look at 10th question.
Last one, 5/3.
Okay. Uh, you mean D is the answer?
No, no, sir. I
Okay, okay.
am.
Some other question you are trying. The earlier one, you are talking about
Uh,
ninth?
no, no, sir. I am just.
Uh-huh.
You have sketched the arbitrary, and I will trying to say, 1 point
Mm-hmm.
would be 1 + 2/3, but it will out of the codomain. That is why you are not drawing that point. If
Uh,
it
no,
is,
which
it will.
one?
It
It
is
will be
not occurring.
inside. Because here it is 0 to 1/3 only.
Okay.
So the codomain is also close 0, 1. I mean, you are going to remain in the box 0, 1 cross 0, 1. So a quick plot will suggest it is X over 0, 1, but only rationals. So what will happen is over rationals. So I'll have 1, the image of 1 is 1, image of 0 is 0, it is rational. Image of every other rational is shown with these dots. You get it? These are images of all the rational numbers
Yes.
between 0 and 1. By this.
Sir, it is not.
Now, huh, yeah.
So it is not continuous on rational intersection 0 1.
On the rational. So you want to say it's continuous at every irrational?
No, sir. I mean to say that option C is wrong. That is, it says that f is continuous on Q
Correct.
intersection 0 1.
So
So it is wrong actually.
yes, that is wrong. That's not true. Good. Yes. So how about the other two? areas like 0 to 1 by 3 if I am looking at. So of course x is not a rational, but if I take x as 0, what would be the image? 2 by 3, right? As a, I mean, just to guess what is the behavior, I'm just plotting it. So 2 by 3, and at 1 by 3 it is 1. At 1 by 3 this expression is, I'm trying to plot the line. Then on that line I will take only images of irrationals. You realize what I'm doing? So the line will be something like this. At this is 1, but this point is not in the on the graph. Understood? So these are images of irrationals between 0 and 1 by 3. So that is this part. And then what about this? 1 by 3 to 1, it is x minus 1 by 3. So at 1 by 3 it is 0. Of course, it's not the part of the, it is not the part of the graph. Okay. And at 1, it is 1 minus 1 by 3, that is 2 by 3. 2 by 3, this height. So these 2 points are not the part of the graph, but everybody on this line, irrationals, images of irrationals will fall on this line. You get the sketch? That is what this is. Now, what is the answer? Immediately you can say it is discontinuous everywhere. That is very clear, right?
Sir, it is not 1 1.
Yeah, okay. It is not 1 1. Why?
Sir, because when we, sir, we can see that by vertical line test, it will have two
Hmm.
images.
Which two image? Which vertical line? If I take this vertical line, suppose.
Sir,
Sorry,
yes.
vertical line. Vertical line.
No, sir, horizontal line. Sorry.
Ah,
Actually,
okay.
vertical line is a for taking function is or function is not.
Function. Okay. So if I take horizontal line, but
Yes, sir.
suppose it is at which points? Okay, I'll
Sir,
take it at 1 by 3.
yes, sir.
Now, see,
Sir,
problem is, huh? Yeah,
sir,
yeah.
in the x axis, to after 2 by 3,
Uh,
we can see that there is no, sir.
uh, problem is on this line there will be irrationals. See, if x is irrational, x minus 1 by 3 is going to be irrational. So these points that we have plotted are all irrational numbers. So 1 by 3 won't be, it will be caught only once. That is 1 by 3, the image is 1 by 3. Now, if I would have taken any irrational, suppose r is a irrational number, and I look at pre-image, then it will not appear here because these are images of rationals. So it will appear uniquely here only. Is everyone catching it out? What I'm
Yes,
saying?
Yes,
yes,
sir.
sir.
So function is looking 1 1. Understood? Because see, point is all rationals are having images on this line
And all
and
irrational this
are
line, huh? It is
distributed on
it
these two lines.
it can be, it might be 1 1.
It is 1 1 actually, because if you take any, same thing applies to this also. If you take any rational between 2 by 3 and 1, then the image is going to be here only here. I
Yeah.
mean, the pre-image
Yes.
over here only. And if you take irrational, then the pre-image will fall on this. It won't go over here at all because these are all rationals,
Yes.
rational numbers. Understood? So that's the idea. So it is 1-1. And how about ontoness? Is it onto?
Yes, sir, because if we draw the vertical line in this domain, restricted domain and codomain, there are at least 1 point which will cut the graph, at least one.
Right, right. Actually, horizontal line only.
Yes.
You have to look at all horizontal lines,
Mm.
and whatever line you draw, if it is
The
drawn at rational,
rational
then it will cut here. Yeah,
and irrational, then it will also cut somewhere in this
correct,
line.
correct. It has to cut.
So on
So
and
if
on.
yes, it is 1-1 as well as onto.
Sir, it is very good representation of this function, bijective and also nice.
Right, right.
But
Yeah, yeah.
sir,
Uh,
like thinking such type of function is very helpful in some proving or disproving.
correct, correct, correct. Good, good. So even continuity is not there. That is very clear from the
Yes.
picture, and this is then out of question. But I have some more questions about this. Because we have the graph.
Mm.
What about, does it satisfy intermediate value property? It's not continuous is fine, but does it still satisfy? Because see, intermediate value theorem says continuity implies intermediate value
Uh,
property. Uh,
Continuity is sufficient condition for getting IVP. It is
Correct.
not necessary.
Not
It is
necessary.
considered.
Very, very good. Right, right. So, is this becoming a counter example, or it
Yes,
is?
yes, yeah. IVP, it is one of the.
We have to think about it.
Yes.
Now, that is again a careful understanding. So, if I take any two numbers in the codomain, for example, if I am taking some numbers, say maybe this point and this point in the codomain, then everybody between these two, not codomain, actually range, then everybody between these two should have a pre-image. Not just that, should have a pre-image between the pre-images of these two. You understand the requirement? What is the requirement for every k such that fa less than k less than fb, there exists c between a and b? That is important, such that f of c is k. Now, can you guarantee that? That's the point. Sorry. Now, this is tricky.
We have to check this.
You have to check that.
Yes, sir. Put a exclamatory sign because when we review this, that will.
Where should I put it? Here?
Yeah, 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 yeah.
Uh, Correct, correct.
Then it will remind us that we have to check this point because
Mm,
this question
right,
also might
right.
come in option.
Correct, correct, correct. Should I disclose the answer or you will check it out?
Sir, we are checking because there are two class left, sir, I think.
Yeah. Okay, okay, okay. Oh, you have another class after this?
Sir. No, sir, till now it is not. You have two classes also, and if we not
Differentiable.
got it, and
Fine,
then we
fine.
will
Yeah,
ask.
yeah, yeah. Correct, correct. Yeah, yeah. You can try it out. Okay. So shall we wind up, because I have already extended 10 minutes. So what I would suggest now is, these questions you can try. This is again L'Hopital, so not a big deal.
Sir, I have a
Other
problem
things.
is
Hmm,
whereas the condition in stated the L'Hopital
hmm,
rule, is it
hmm,
necessary or is it sufficient? And sometimes we are seeing the question and thinking
hmm,
that this limit equal to f dash by g dash, if 0 by 0
hmm,
or infinity by infinity. But is it necessary and or sufficient? This is not, I think, clearly stated in book. Which are usually if you find
uh,
time then
uh,
discuss One.
Fine, fine. I'll discuss that.
Yes, yes.
Actually, sufficient, but I'll clearly give you the statement in the next session
Yes,
when
yes,
we deal with differentiability.
yes, sir. Yes.
The next session we will discuss this. No problem.
Mm.
Yeah, yeah, yeah. Yes. So yeah, even these are simple, means good questions. You can try these, and maybe as we discussed, if any problem you encounter you are not at all able to solve, even with discussion with your peers, then we can revisit. I can disclose the answers. Huh? So fine, is it okay, this strategy?
Yes, sir. Very, very helpful, no doubt. I think
Fine, fine.
your
Good.
teaching style and well spaced, because you are not so fast, not so slow, but in
Yeah,
between, like
yeah.
10 in our. We are
Yeah,
uh, very
thanks,
helpful, sir.
thanks. Good, good, good. Okay, so shall I'll stop sharing now. I will wind up for today. Hmm?
Yes.
Yeah,
I hope there are no more queries left. Uh, Thank you so much for such an engaging and wonderful session, Mandar sir.
yeah, yeah. Thanks a lot. It's my
Uh,
pleasure.
yeah, sir. We
Yeah.
are also honored to have you, sir.
Yeah,
Sir,
thanks.
can we
Thank you.
get
Part
the today's
Yeah,
PPT?
yeah. I'll be sharing this immediately in with I think with Tina, madam. Is it okay? Then she can
Okay, sir.
post it in the
Yes,
group.
yes. No
yes, sir.
problem, sir.
Yes,
Yeah,
sir. Yes.
fine, fine.
Yes,
I'll
sir.
do that.
Sir, one request, sir.
Uh,
If you kindly arrange time, then put some question on point set topology on R. This is only
mm,
okay. And countability and uncountability. There are some question which because countability and uncountability is very much coming in beside
mm.
within the problem of continuity, within the problem of differentiability. There are, I think,
Mm,
please, if you
mm.
manage.
Yeah, yeah. We'll see
Thank
that.
you, sir.
Okay.
Okay,
So
okay, sir.
countability, uncountability, you mean,
Hmm.
no?
Yes,
Uncountable
yes,
sets.
yes, yes,
Fine,
sir.
fine. Let's see. Let's see.
Okay,
Okay. Yeah.
okay.
Okay.
Good evening. Thank you, organizers, sir.
Yeah. Yeah. Yeah.
Thank
Good
you
night.
once again, sir.
Yeah. Okay.
Participants, please note that next session will be on Saturday, 13 December 2025 from 6:30 p.m. to 7:30 p.m. as per the schedule. Let us meet there. Goodbye.
Yeah. Bye.